Assalamualaikum and hi everyone. In this video, we are going to learn about the types of organic reactions. There are three types of organic reactions. The first one is addition, the second one is substitution, and the last one is elimination. For addition reaction, the atoms or groups are added to the adjacent atoms of multiple bond. There are two types of addition reaction, which are electrophilic addition and nucleophilic addition. For the substitution reaction, the atoms or group is replaced by another atom or group. There are three types of substitution, which are free radical substitution, electrophilic substitution, and nucleophilic substitution. For the elimination reaction, the atoms or groups are removed from adjacent carbon atoms to form a multiple bond. It can either be a double bond or a triple bond. Previously, we already learned about the site of reaction. There are two sites of reaction, which are electrophilic site and nucleophilic site. For electrophilic site, it is an electron poor site, where the carbon atom is connected to the more electronegative elements such as oxygen and halogen. This makes the carbon atoms becomes delta plus, and it is an electron poor site, similar to the carbon connected to OH group, making the carbon partially positive charge, as well as the carbon connected to the halogen atom, also partially positive charge. For nucleophilic site, it is an electron-rich site, where the carbon atoms are of the same electronegativity, making the sharing of electrons equal. Therefore, carbon-carbon double bond is an electron-rich site, as well as carbon-carbon triple bond and carbon-carbon double bond in the benzene ring. Please be reminded that this is very useful in order to decide the name for the type of reaction later. Now, let's try this. By comparing the starting material on the left hand side to the product on the right hand side, we are going to determine the type of reaction. For the first question, we can see that this hydrogen and OH group is no longer in the product. Therefore, it is decided that the type of reaction for this reaction is elimination. Now, take a look at the second question. By comparing the starting material on the left hand side and the product on the right hand side, we can see that the hydrogen atom here and the chlorine atom here is no longer in our product. Again, it is an elimination reaction. Now, let's proceed to the third question. By comparing the starting material and the product, we can see that the bromine atom is added to these two carbons. Therefore, it is an addition reaction. However, we know that there are two types of addition reaction, which are nucleophilic addition and electrophilic addition. In order to decide that, we need to take a look at the site of reaction, which is the carbon-carbon double bond in our starting material. Carbon-carbon double bond is an electron-rich site. It is a nucleophilic site. Now, we can decide that bromine is a electrophile. The name of the type of reaction depends on what attack our nucleophilic site. Therefore, electrophile is the species that will give the name, which is electrophilic addition. Now, let's take a look at this question. By comparing the starting material here and the product here, we can see that the CN group is added to this carbon. Therefore, it is an addition reaction. To decide whether it is an electrophilic or nucleophilic addition, we need to take a look at the starting material where the site of reaction is. This carbon is connected to oxygen, which is more electronegative than carbon. Therefore, this carbon is an electron poor site. Electron poor site is an electrophilic site. Therefore, we know that Cn is a nucleophile. Since the nucleophile is attacking our electrophilic site, so the name for this type of reaction is nucleophilic addition. Let's move on to the next question. By comparing the starting material and the product, we can see that the difference is this bromine atom, where initially it is hydrogen atom attached at the same carbon. Therefore, it is a substitution reaction because we substitute the hydrogen atom with bromine atom. Now, we want to decide whether the substitution is electrophilic, nucleophilic, or free radical substitution. There are three types of substitutions. Therefore, we take a look at the site of reaction, which is this carbon. Again, carbon-carbon double bond is an electron-rich site. Therefore, it is a nucleophilic site. From this, we can decide that bromine is an electrophile. Now, we can give the correct name for the type of the reaction based on what species attack our nucleophilic site, which is electrophile. Therefore, the name for the type of reaction is electrophilic substitution. For the next example, we can see that in this starting material and this product, it differs by OH group in the product, while in the starting material it is bromine. So it is a substitution reaction. Again, we have three types of substitution reactions, which are electrophilic, nucleophilic, or free radical substitution. In order to decide whether it is electrophilic or nucleophilic or free radical, we take a look at the site of reaction, which is this carbon. This carbon is connected to bromine, which is more electronegative than carbon. Therefore, it makes the carbon electron poor site. Electron poor site is a electrophilic site. Therefore, the hydroxyl group attacking our electrophilic site is a nucleophile. So, nucleophile is the species that responsible to give our name for the type of reaction nucleophilic substitution. Now, let's move on to the last example. As we can see, here our starting material is an alkane, and the product is a haloalkane. Alkane is relatively unreactive. However, when we react it with halogen, with the presence of UV light, there will be a reaction, and it is very specific. Firstly, as we can see here, the hydrogen atom at this carbon is replaced with chlorine atom. Therefore, it is a substitution reaction. Now, it is neither and electrophilic or nucleophilic substitution. This is due to the unreactivity of alkane. Only reaction with halogen with the presence of UV light, then only the alkane will react. Therefore, it is a very specific reaction which is free radical substitution.